Question 1. Differentiate with respect to x. Okay, this, guys, is a product rule. So I'm going to do u equals 6e to the 3x squared and v equals cos 2x. Then I get u dash is, this is a chain rule, guys. So it's 6e to the 3x squared times the derivative of this 3x squared, which is 6x. So that actually becomes 36x e to the 3x squared. And then here, dv dx, also a chain rule. This will become negative sine 2x. I left a bit of space there because it's times 2, because it's times the derivative of this. Okay, therefore, dy dx is u v dash plus v u dash. So I'll just do this times this first, which will give me negative 12 e to the 3x squared times sine 2x plus this times this, which is 36x e to the 3x squared times cos 2x. Okay, that is question 1. Question 2. Using the axes below, sketch the line with these equations. Okay, so I need y equals 6. Okay, let's go with, well, actually, let's do this one first, just so I need to see what kind of scale I have. So y plus x equals 10. So guys, I like to do these by saying, I do x and y. Then when x is 0, y is 10. And when y is 0, x is 10. So I have 0, 10, and 10, 0. I'm going to go with, let's say that's 10 here. And then I'll just keep the same scale. Let's say that's 10 here. And then this will be the line. I might just move that point, guys. But that's the line. Y plus x equals 10. Okay, just going to move this point here. Okay, and this is obviously this 10. Okay, so this is the line y plus x equals 10. Okay, then y equals 6. Okay, well now I can just draw that. Obviously, guys, you don't have to use different colors, but let's say 6 is about here. I'm going to use different colors. This is y equals 6. And then 2x minus 5. Okay, well now I need to go to down here. I can go 2x minus 5, so it's going to cross the y-axis at minus 5 here, and there will be a gradient of 2. Okay, so it'll go something like, okay, if that's, well, that would be 5, gradient of 2, I don't know, something like this. And then let's go back down here like this. Okay, this is y equals 2x minus 5. And okay, well that's those 3. Then he says show by shading on the region the line that satisfies these 3. Okay, so, and I have to put or. So y is less than 6, so it's below this guy here. Y plus x is less than or equal to 10, so it needs to be, well, down this side. You can sub in a point, guys. If you sub in 0, 0, is 0 plus 0 less than or equal to 10? Yep, so it's down here. And then y is to be greater than 2x plus 5. So again, I will sub in 0, 0. Is 0 greater or equal to negative 5? Yep, so it's this side of this line. It's the side of this point. And then finally it says x is greater than 0, so it has to be over here. So it's basically this here. Now just be careful, guys, that here it's to the left of that blue line, and it can go below the x-axis. So it's here, and he says label it R. So there you go. Okay, that, guys, is question 2. Question 3. Figure 1 shows the right pyramid ABCDE Okay, base here, height, this is all given. Okay, fine. The sloping edges, they're all equal length. Calculate to 3 significant fingers the length of the sloping edge. Okay, so he basically wants, guys, this edge here. Let's use this one. So these are all the same. He wants this, and I can, well, I know the 14, and I can get this length because it's half of AC, which I can get using Pythagoras' theorem. So let's do that first. Okay, AC squared equals 12 squared plus 16 squared. Now this, guys, is actually one of those nice triangles where AC, this is part A, guys. It's like my 3, 4, 5 triangle, but it's multiples of, or if you multiply 3, 4, 5 by 4, you get 12, 16, and 20. So A is equal to 20. If you want me to show you why that's the case, it's 144 plus 256. That's 400. Square root of 400 is 20. So AC is 20, which means MC, therefore MC is equal to half of that, which is 10. And then I want the sloping edge, which is, let's call it EC. So I have EC squared equals 10 squared plus 14 squared. EC is the square root of 10 squared plus 14 squared. So let's just do that here. It's the square root of 10 squared plus 14 squared, which is this. He wants it in decimal form, so it's 17.2 to 3 significant figures, 17.2. Okay, part B. Calculate in degrees to 1 decimal place the size of the angle between AE and the base. So AE and the base. Well, I think that's pretty easy, guys, because this is 10. We know this length, although we don't even need it because I have the 10 and the 14. So looking at this blue triangle, that's 10, that's 14, that's a right angle. He wants this angle here, let's call it theta. We can say tan of theta equals 14 over 10. So theta is the inverse tan of 14 over 10. Inverse tan of 14 over 10, 0.95. Now I'm in, guys, radians. I think he wants in degrees, so I need to change out of this into degrees. Degrees. Back. Try that again. 54.5. So 54.5 degrees. Part C. The angle between the plane AED and the base. So AED and the base. Now I'm just going to erase this, all of this for a second. So just so you understand what's happening here, it's this front plane and the base. So the way we do it is we need the line of intersection between the planes. That's this line here. That's where the planes intersect, at this line. And then I need a line along each plane and perpendicular to this. So the one along the base will go from the middle. And if that's 16, that length is actually 8. And then I want this line here straight up here. Now, that line I'm gonna have to get from this triangle here, this AE, whatever this point is here. Let's call it, I don't know, let's just call this point P. Okay, so let's say, let's use green. This triangle here okay, so this has to be 6 because it's half of that 12. This we know is 17.2. That's the kind of, well, the answer to A. And this angle here, or sorry, this length is what I'm trying to get. Let's call it x. So x squared plus 6 squared equals 17.2 squared. X squared equals 17.2 squared minus 6 squared, and then x is the square root of that. So it's the square root of 17.2 squared minus 6 squared. Square root 17.2 squared minus 6 squared is this to decimal 16.12. So this is 16.12. So that's this length here. This length is 16.12. So the angle that I'm trying to get is this guy here. Let's call that angle, well, let's just call it alpha. So I'm going to say the cosine of alpha. And I've just realized something stupid, guys. I didn't even need it. I didn't even need that 16.12 because I had the 14 and I had the 8. So I could just say tan of alpha. Tan of alpha is 14 over 8. So alpha is inverse tan of 14 over 8. Inverse tan of 14 over 8, which is 60.3. Okay, so guys, that was a silly thing to do, wasted time, but if you needed it, that's how it's done. Okay, that is question 3. Question 4, figure 2 shows the graph of this drawn on the grid. By drawing a suitable straight line on the grid, obtain estimates to 1 decimal place for the roots of this equation here. Okay, so we have, guys, what do we have? We have this, and then we have this. So essentially what we want to do, guys, is we want to change, the trick with these questions is you want to change the left-hand side into this graph, or into this, because this is the graph. So I want to change this into x plus 5 over x squared. Now, how do I do it? Well, my first thought, because he's got a 5 over x squared, is just divide by x squared. Why do we do that? I'll divide both sides by x squared. That will give me x minus 4 plus 5 over x squared equals 0 over x squared, which is 0. And then, what do I have here that isn't there? Well, there's a minus 4. So I just add the 4. So I get x plus 5 over x squared equals 4. So now I have the graph equals 4. So I just draw the line y equals 4. Now I might even write here, guys, draw y equals 4. So get y equals 4 here, draw a line across. Where it hits the graph is obviously my solution. So one is here, that is 1.4, and one is here, that is 3.6. So it's 1.4 and 3.6. X equals 1.4, x equals 3.6. Okay, part B. By drawing another suitable straight line on the grid, obtain an estimate to 1 decimal place for the root of this equation in this interval. Okay, so this is quite similar to this. So, okay, so let me just start again, guys. I think this is the way to go. So I'm going to go x cubed minus x squared minus 5 equals 0. Same idea. I want to get this. So this is going to be a bit more tricky, guys. So I'm going to divide everything by, x squared. Let's do that anyway. So divide everything by x squared. That gives me x minus 1 minus 5 over x squared. Okay, and this is equal to 0. Now there's a positive 5 over x squared. So what I'm going to do is I'm going to add that to this side. So I'm going to get x minus 1 equals 5 over x squared, because I'm adding this to the right. Okay, but now I need 5x squared plus x, so I need to add an x to this right. So it's 5 over x squared plus x, and then obviously if I add x to the right, I add x to the left, which gives me 2x minus 1. So I draw y equals 2x minus 1. Okay, 2x minus 1. When x is 0, y is minus 1. That's not good. When x is 1, y is 1. Okay, fine. When x is 1, y is 1. And when x is 4, no, that's not good. When x is 2, y is 3. So I'll just draw a line there. Okay, so I'm drawing this line, guys, through there, and I get, okay, something like that. Now where that hits the x-axis, or sorry, where it hits the graph is my solution. So that's like, I don't know, 2.15 or something like that. Does he want it to one decimal place? So I'm going to just put it as, I think it's closer to that one, guys. So I'll put x equals 2.1. Okay, that is question 4. The points P, Q, R, and S have these coordinates. Show by calculation that the line P, R, and QS are perpendicular. Okay, so guys, we just have to get the gradient of PR and QS. So MPR is, this is P and this is R. So it's y2 minus y1, so 1 minus 7 over x2 minus x1, which is 10 minus 4. This is minus 6 over 6, which is equal to minus 1. And then MQS is equal to, that's Q and that's S, y2 minus y1, 8 minus 0 over 11 minus 3, which is 8 over 8, which is 1, which I was expecting. Now guys, it's a show that question, so you do have to show that when you multiply the gradients together, minus 1 times 1 equals negative 1. If it's perpendicular, then when you multiply the gradients together, you will get negative 1 because it's the negative reciprocal. So you can just do that and then say therefore perpendicular. Okay, B. Find the exact lengths of PR and QS. So PR is, exact length is x2. So x2 minus x1 squared. So 1 minus 7, x2, 10 minus 4 squared plus y2 minus y1, which is 1 minus 7 squared, which is the square root of, well, that's 6 squared, which is 36, and that's also 6 squared, 36, so it's 36 plus 36, which is root 72. Root 72, guys, if you want, is actually root 36 times root 2, which is 6 root 2. Okay, so that's PR. Now let's get QS. I'll just draw a line here, guys. QS is equal to, same idea, square root of 11 minus 3 squared plus 8 minus 0 squared. This is the square root of, well, it's 8 squared plus 8 squared, 64 plus 64. This is the same kind of thing, guys. It's 264, so it's going to be 8 root 2. But that's root 128, which is equal to root 64 times root 2, which is 8 root 2. Part C, find the area of the quadrilateral PQRS. Okay, so we've got, guys, that PR and QS are perpendicular, so the diagonals are perpendicular. So these are the diagonals here and let's say here. Now, the mark scheme, guys, actually says that this is a kite, but I'm sure it is. Without actually finding the lengths of all the sides, we can't actually be sure it's a kite, but we can still use the same formula. If the diagonals meet at right angles, so let me just show you what I mean. This is P, this is Q, this is R, and this is S. Now let's just assume it's not a kite, even though we know it is. Well, sorry, I know it is from the mark scheme, but at the moment doing this question, I don't really know what it is. So what I do is, here's my quadrilateral that I'm trying to find the area of. This P, Q, R, S, like so. Now what we can do is, we can say that if you do this times this and half it, you can get the area of the full thing. Why is that? Why does that work? Well, it works because if I do this times this, I basically get the area of this rectangle here. Like that. Now this rectangle, sorry guys, do that a bit better. This rectangle here, this rectangle, you can see that this purple area is like half of that rectangle. This purple area is half of that rectangle. This purple area is half of that rectangle. And this purple area is half of that rectangle. So the entire purple area would be half of the big blue rectangle. So what that means is the area is equal to this times this divided by 2. 8 root 2 times 6 root 2 divided by 2. Now root 2 times root 2 is 2, so those cancel, and I'm left with 8 times 6, which is 48. Okay, that, guys, is question 5. An arithmetic series A has first terms little a and common difference d. The sum Sn of the first n terms is given by this. Find the value of a and the value of d. And then find the 20th term of a. Okay, so let's do obviously part A first. The value of a and the value of d. So, okay, I can find the first term. The first term is just S1. It's the sum of 1 terms is obviously the first term. So that's just 1 times 15 plus 2, which is 17. The value of d is then S2 minus S1. So, no, actually, sorry, that's not even true. The value of d, be careful, you have to get from getting U2 minus U1. So first let's get S2. So S2 is equal to 2 times 15 plus 4, which is 38. Okay, so this means U1 is 17. Be very careful here, guys. I've seen many people make this mistake. So U1 is 17, and U2 is 38 minus 17, which is 21. So if U1 is 17 and U2 is 21, what is D? Well, D is actually 4. So U1 is 17 and D is equal to 4. Okay, part B. Find the 20th term. U20 is U1 plus n minus 1 D. So that's 17 plus 19D, or 19 times 4. 17 plus 19 times 4. 19 times 4, guys, is 76. 76, 86, 93. This is 93. Then part C. Given that S2P minus, let me just put this up here, guys, out of the way, part C. S2P minus 2SP equals 1 plus SP minus 1. Find the value of P. Okay, so obviously let's just get all of these different things. So S2P first. S of 2P is just 2P times 15 plus 2 times 2P, which is 4P. And then I guess, well, let's just leave it like that for now. And then 2SP is just going to be 2 times P. I'm just subbing P in here. So it's 2 times P, 15 plus 2P. And then S p minus 1 is equal to p minus 1 times 15 plus 2 times p minus 1. Sorry, p minus 1, like this, like this. I think I'll just write this as p minus 1 times 15 minus 2 is 13 plus 2p. Okay, so apparently this minus this equals 1 plus this, so let's write that out. This 2p into 15 plus 4p minus this 2p times 15 plus 2p equals 1 plus this, which is p minus 1 times 13 plus 2p. Okay, now I have my equation. I just have to find p, and we'll get it, guys, by multiplying things out. Okay, this is 30p plus 8p squared minus 30p minus 4p squared equals 1 plus 13p plus 2p squared minus 13 minus 2p squared. Okay, so sorry, what am I doing? Minus 2p, that's not squared. Okay, these cancel nicely. This just becomes 4p squared. 1 minus 13 is minus 12. Minus 12 and 13p minus 2p is plus 11p, and this is just 2p squared. Subtract that over here. I get 2p squared. So 4p squared minus 2p squared is 2p squared. 2p squared minus 11p and plus 12 equals 0. This is a quadratic that we need to factorize. I'm going to do it my quick way, guys. 2p and p. I need 4 and 3. I need minus and minus. So 2p minus 3 equals 0. P minus 4 equals 0. P equals 3 over 2. And p equals 4. Now, let me just check, guys. What does p have to be? Well, p, it's the number of terms, guys, so p has to be a positive integer. I'm going to say p is an element of positive integers, therefore p equals 4. Okay, that, guys, is question 6. Given that f of x can be written in this form, find a and b. Okay, that, guys, is basically, well, it is completing the square. So I can write this as f of x equals x minus, we half the 9, so that's 9 over 2, squared. We subtract 9 over 2 squared, and we add 14, and then this equals x minus 9 over 2 squared minus, that's 81 minus 81 over 4, and this would be 56 over 4, which is minus 81 plus 56. That is 25, guys. I believe that is minus 25 over 4. Okay, so a is equal to negative 9 over 2, and b is equal to negative 25 over 4. Okay, part b. Hence find the minimum value of f of x. Okay, that's just negative 25 over 4. And then where does that occur? When x equals 9 over 2. That's the whole point, guys, of completing the square. Okay, part c. The curve C has equation y equals f of x. The line this equals, sorry, the line has L has equation y equals x plus 5. Use algebra to find the coordinates of the points of intersection. So we can just equate them. So we have x squared minus 9x plus 14 equals x plus 5. Rearrange x squared minus 10x plus 9 equals 0. We can factorize this nicely, guys. This is x minus 9 times x minus 1 equals 0. Therefore, x equals 1 and x equals 9. Now be careful, he wants the y value as well. So for x equals 1, well, let's do f of 1 is equal to 1 minus 9 plus 14, which is minus 8 plus 14, which is 6. And f of 9 is 9 squared minus 9 times 9, which is 0, plus 14, which is 14. Therefore, the coordinates are 1, 6 and 9, 14. Okay. Part D, use algebraic integration to find the exact area of the finite region bounded by C and L. Okay, so I can just do, guys, the integral of this minus this from 1 to 9. Okay, so I'm going to do the integral from 1 to 9 of f of x. Now f of x is x squared minus 9x plus 14. X squared minus 9x plus 14. And I'm going to subtract x plus 5. So minus x plus 5 in a bracket dx outside this whole thing. And that, guys, will give me the area. If the answer to this is negative, then I'll just go back and do that. I can do that right now if I want. But to be honest, considering, guys, that my quadratic is, well, actually, sorry, my quadratic is like this, it probably will be negative because I'll have the line minus the quadratic the line minus the quadratic would give me the positive answer. So this is probably going to give me a negative answer. When it does, I'm just going to say the area is equal to the modulus of this. In fact, I'll put it in right now. So that becomes, well, let's just multiply this out first. So it's x squared, that's minus 9x minus x is minus 10x, and then the 14 minus 5 is the plus 9 dx. Let's integrate. This is x cubed over 3 minus 10x squared over 2 plus 9x from 9 to 1. Sub in the 9, that's 9 cubed over 3 minus, that's 5, guys, that's 5 times 9 squared plus 9 times 9, subtract, sub in 1 over 3 minus 5 plus 9, close this, and I get, I'm just going to do this on the calculator, guys, because this is too much work. Okay, I get 9 cubed over 3 minus 5 times 9 squared plus 9 times 9, and then minus, this is all going in a bracket, so it's 1/3 minus 5 plus 9, and I get minus 256 over 3. So this is minus 256 over 3. Again, this is all modulus, 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 modulus. So this equals 256 over 3, which I think, guys, is actually correct. Okay, that, everyone, is question 7. Given that dxy plus 5y equals e to the x, show that dy dx equals this. Okay, so first, guys, we want to rearrange this so that we have y the subject. Now, the best thing to do, I think, is we factorize out the y here, take out the y, and we have 2x plus 5 equals e to the x. Then we divide by that, so we have e to the x over 2x plus 5. And now we can use a quotient rule. So dy dx is equal to v times du dx. So let me just write u and v over here, guys. U is e to the x. V is, v is 2x plus 5. Du dx is e to the x. And dv dx is 2. So we do v times du dx. So that's 2x plus 5 times e to the x. And minus, so v times u dx minus u times dv dx, all over v squared. V squared is 2x plus 5 squared. Okay, so that's dy dx, but we need to show that it equals this. Now, remember, y is this thing here. So what we can do is, okay, I can see how this works. We can take out an e to the x on the top, which gives us up here 2x plus 5, and then minus 2, because I've taken out the e to the x on the top, factorized it out. And then this is like, well, this is obviously 2x plus 5 times 2x plus 5. Now this is equal to the e to the x over 2x plus 5 is y, e to the x over 2x plus 5, so that's y. And this is just 2x plus 3, 2x plus 3, because 5 minus 2 is 3, and then all over 2x plus 5. So we're done. Okay, B, I'll go to here. Find the value of dy dx when x equals 0. Okay, hopefully not difficult, guys. When x equals 0, okay, so dy dx is in terms of x and y, so let me just make sure I get y first. So when x equals 0, y equals e to the 0 over 0 plus 5, if you like, which is 1 over 5. Okay, so dy dx is equal to, now I'm going to sub in 0 and 1 over 5 in here. So y is 1 over 5. 0 is 0, so that'll just become 3. And then that is all over 2. So this becomes, guys, have I done something wrong? Sorry, that's not 2, that's 5. So it's 2 times 0 plus 5, which is 5. So this is 3 over 5 divided by 5, which is 3 over 25. Okay, finally, part C, which hopefully I'll fit here. Find an equation of the normal to the curve with equation of this at the point where x equals 0. Okay, so remember, guys, to find the equation of the normal, I need a point and I need a gradient. My point I have, it's 0, 1 over 5. And my gradient, my m if you like, is, it's the normal, so it's the negative reciprocal of this. So it's negative 25 over 3. Now, once I have that, I'll sub into my formula. My preferred formula, guys, is y minus y1 equals m into x minus x1. Feel free to use y equals mx plus c if you want. This is y minus a fifth equals m into x minus 0, which is just x. Okay, then I'm going to multiply across, guys, by 15, because the 15 will remove the 5 and the 3. So 15y. This times 15 is 3. And this times 15 is 5 times this, which is minus 125x. He wants x plus y plus z equals 0. So let's add this over here. 125x plus 15y minus 3 equals 0. That, guys, is question 9. Figure 3 shows triangle ABC with all this information that is given. Okay, fine. So just note D is in the middle of this, guys, which immediately makes me think, well, that's x and that's x, because that whole thing is 2x. Okay, show that cos ADB, that is this one here, cos ADB, is equal to this. Okay, this is definitely, guys, a cosine rule. So I'm going to say cos ADB is equal to, cosine rule, guys, is this squared plus this squared minus this squared. So it's x squared plus 6 squared minus 12 squared all over 2 times 6 times x. Now, that is equal to x squared minus 36, guys, minus 144 is 36 minus 144, I would assume, is that. Let me just make sure that's true. 36 minus 144 is minus 108, yeah. So minus 108 over 12x, which is given. Okay, part B, Q, E, D. Hence or otherwise show that AC equals 6 root 6. Okay, now this question, guys, I actually find to be quite tricky. So you could, okay, the way the mark scheme actually wants you to do this is they said, well, this angle here, let me just write this out, angle BDC. So angle BDC is equal to 180 degrees minus angle ADB. Now, if you remember from our unit circle, or however you want to remember this, guys, or however you understand it, if we have theta here, and this angle, let's say that's theta, but this angle is 180 minus theta, then we have this. We know that cos of 180 minus theta is the same as the cos of theta, but negative. Is equal to negative cos theta. So let me just put this to the side here. I'm going to show you there's two ways to do this, guys, and I actually think that normally when someone says hence, I say just stick with the hence way, and this is the hence way. But there's another way to do this question, which is possibly easier and probably the way I would have done it. So we've this to be true from our unit circle. So that means the cos of BDC, must equal negative of this. So that must equal negative, well, x squared minus 108 over 12x. Okay, and then we can get cos of BDC using, again, the cosine rule. Cos of BDC is equal to this squared plus this squared minus this squared, x squared plus 6 squared minus 6 squared over this squared plus this squared minus this squared over 2 times this over 2 times 6 times x. Okay, so that's actually the exact same. No, sorry, it's not the exact same thing because there's no 12. Okay, those cancel here, so that equals x squared over 12x. Okay, so now I can equate these two things. So this must equal this. So I have minus this. Now I'll just multiply that out, guys, if you're okay with this, and write 108 minus x squared. So I've just changed the signs here and got rid of that minus. That equals x squared over 12x. Now these 12x's can cancel. Add the x squared over here. I get 2x squared equals 108. Let's go down here. X squared equals this is 54, which means x is equal to root 54. Now root 54, guys, is 9 times 6, so this is equal to root 9 times root 6 which is 3 root 6. Now guys, we need to find, that is x, but we're trying to find 2x because we're trying to find AC. So if x is equal to this, then AC, well, let's write it here. AC equals 2x, which means AC equals 6 root 6, which is 2 of these. Okay, so that's pretty complicated, guys, particularly the first bit. The other way to do this question is you get the, and I think this is the more, to me, the more normal way. You get the cosine of this using cosine rule, using this small triangle. So that would be this squared plus this squared minus this squared over 2 times this. And then you also get it with the big triangle, which would be this squared plus 2x squared minus 6 squared over 2 times 12 times 2x. And you equate them and then solve it. I think that would actually be easier. Anyway, that is part B. Next, part C. Show that sine of theta plus phi is equal to sine of phi. Okay, now this, guys, isn't obvious either, but I'm thinking sine rule, and I'm thinking there's something going on here with the big triangle and the smaller triangle. So if I do think of this, like, let's do a sine rule with the big triangle. So that will give me immediately my sine of theta plus phi. So that over the, let's go with this big length here, over 2x is equal to, now if I'm gonna do the big triangle with a small triangle. Now if he wants sine phi, I'm going to use this small triangle, and then which angle is in both the big triangle and the small triangle? Well, it's this one here. So let's just use this for now, even though I don't know what it is. I'm just going to say this is sine DCB. Let's just call it DCB for now. So sine DCB over 6. So sine of this, oh sorry, that's not over 6, it's over 12 because I'm doing the big triangle. So big triangle, this over 2x over big side equals sine of this over this side. Okay, fine. And then I'm going to do sine, okay, let me, guys, just move all this to the side just for now. Okay, then here I'm going to do the small guy, small triangle. So I'll do sine of phi over x now. So sine of phi over x, I'm just in the small triangle, equals sine of, again, DCB, and this time over 6. Okay, now I want to somehow kind of equate these. So what I'll do is, let's just get sine DCB on its own. So sine DCB, I'll get sine DCB for both of these and then just equate them. So sine DCB is 12 times this, or if I can cancel the 2's, guys, it's just 6 sine theta plus phi over x. And then this sine DCB is equal to also 6 sine, well, sorry, 6 sine phi over x. So this is sine DCB and this is sine DCB, therefore they're equal. So I can say 6 sine theta plus phi over x, that's this guy here, equals 6 sine phi over x, that's this guy here. Multiply across by the x, that cancels, divide across by 6, that cancels, and we're left with sine theta plus phi equals sine phi, which is what we wanted. Okay, last part, part D. Hence show that theta equals 180 minus 2 phi. Okay, so I think, guys, in this situation, we are going to say, okay, well, if sine of this equals sine of this. So sine of theta plus phi equals sine of phi. Then that means that, okay, so that means that theta plus phi must equal sine of 180. Sorry, what am I doing? Not sine of that. This must equal 180 minus phi. Now, let me explain why that is the case. In, again, our unit circle. In our unit circle, if this is phi, okay, let's say this is phi here, and he has the same sine as some other angle over here. Now this is phi there, which means this angle has to be 180 minus phi. So if the sine of phi must equal the sine of 180 minus phi, which means theta plus phi must be 180 minus phi, if that makes sense. Okay, and then I can just rearrange this. Let me just move this over here. I can rearrange this to be, add the phi over here, so I get theta plus 2 phi equals 180, and then what does he want? Oh, sorry, he wants theta. Sorry, I could have just done that in one move, but whatever. Theta equals 180 minus 2 phi. Okay, so that entire question, guys, is quite confusing. So I hope that makes sense. Question 10. Figure 4 shows a right circular cone with, okay, this is shown the area of the curved surface of the cone is A, by considering how the sector, okay, blah, 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 prove A equals pi over L. Okay, so if you've never seen this before, guys, you can get a sector of a circle and kind of join these two corners, if you like, together, and that forms the base circle. The L becomes the circular base of the cone, and this is the pointy bit of the cone. So because of this, like your big R here, this big radius of the sector, is equal to the slant length of the cone. And the circumference of the circle, the circumference of this circle, 2 pi R, is equal to the length, the L. Okay, so what we can do is we can get, so the area of the curved surface of the cone is equal to the area of the sector. Now, what's the area of a sector? Well, the area of a sector is a half. It is a half R squared theta. So it's a half capital R squared theta. That is the area of a sector formula with this R and some theta here. And what is the length of this arc? Well, the length of the arc is, the length of an arc is just R theta. So that's R theta. So we now know that 2 pi R equals 2 pi R equals R theta, because we know 2 pi R is L. So then, because we don't really want a theta in this, well, we don't want an R either, but we certainly don't want a theta. So let's make theta the subject here. So it's 2 pi R over capital R, which means this area is a half R squared theta, which is 2 pi R over big R. Now, the 2's are going to cancel. One of the R's is going to cancel. So we're just left with pi, little r, big R. But we know the big R is L, so it's just pi R L. Okay, not simple, but fine. Part B. Sand is poured onto a horizontal surface at a constant rate of this. The sand forms a pile in the shape of a right circular cone with its base as the surface. Now, I often write, guys, this is dV dt. It's the volume, centimeters cubed per second. It's volume per time. Okay. The curved surface area of the cone, A, increases in such a way that the height of the cone is always 3 times the radius of the base of the cone. So the height is equal to 3r. Okay. I'm just going to move down here, guys, because I don't actually need any of that. Okay. Given that dA dr is equal to k pi r, where k is a constant, find the exact value of k. Okay, so let me actually draw a cone, guys. So we have a cone here like this. This is a bad cone, but whatever. Now, we know that the height, this height here, is 3r. So this is 3r, and then obviously this length here is just 1r. Okay. The curved surface area of the cone. Now we know from part A that the curved surface area of a cone is equal to pi r L. Okay. Now L is this guy here. Now if this is 3r and this is r, we can find L by using Pythagoras' theorem. So L squared equals 3, well, sorry, it would be 9r squared plus r squared, which is 10r squared. So L is equal to root 10r squared, which is equal to root 10r. Okay, so A is equal to pi times r times root 10r, which is equal to root 10 pi r squared. Okay, that's the area of the cone, but we don't want that. We want dA dr. So dA dr is equal to 2 root 10 pi r. So we're done, because he says what is the value of k? Well, k is 2 root 10. So I'm going to say, therefore, k equals 2 root 10. Okay, part C. Calculate the rate in centimeters per second square, centimeters squared per second, to 3 significant figures at which the curved surface area of the pile is increasing when the height of the pile is this. Okay, so we want to find d. What are we trying to find, guys? We're trying to find this, and what is that? That is dA dt. So be careful. The rate at which the curved surface area is increasing. So we want to find dA dt. Okay, how do I get dA dt? Well, I've got a dV dt here, guys. So I'm gonna get dA dV times dV dt. Okay, that will help me get, I'm gonna move this out of the way, everyone, over here. Okay, this is gonna help me get dA dt. Now, how do I get dA dV? That's a weird one to get. Okay, so to get dA dV, I need to bring in another variable. dA dV, this will be dA dr times d or dV. Okay, now we have dA dr. It's this. It's 2 root 10 pi r times, what is dr dV? Well, I'll have to do it down here. I need to get the volume first in terms of r. So volume of a cone is 1/3 pi r squared h, but my h is actually 3r, so I'm going to put it like this, and then we can simplify this. The 3's cancel. It's actually just pi r cubed. Now I want dv dr. dv dr is 3 pi r squared. Okay, and if dv dr is this, what's dr dv? Well, we flip it, so this actually becomes 1 over 3 pi r squared. Now, I'm aware, guys, this question is tricky, and I'm figuring it out as I go along, so if there's an easier way to do it, fair enough. Okay, so those pi's cancel, and this r cancels, so I'm left with 2 root 10 over 3r. So now here I'm going to write this is equal to 2 root 10 over 3r. So the 2 root 10 and over the 3r times dv dt. dv dt is 1.5. Now, he says, the only thing I haven't used yet, guys, is when the height is 24. So when the height is 24, the radius is 8, because it's just 1/3 of this. So that this becomes 2 root 10 over 3 times 8, well, which is actually 24, but let's just put it in 3 times 8, times 1.5. And this, hopefully, will give me the answer to 3 significant figures. So I have 2 root 10, 2 root 10 over 24 times 1.5, and I get this, which is 0.395, which is correct, thankfully, guys. That is 0.395. Okay, another difficult question, guys. This paper, in fact, is difficult. That was question 10. Question 11. Okay, figure 5. We have OA is equal to A. So let me just put that in first, guys. OA is A, and OB is B. Now, we don't have B, but it says the point C divides OB in the ratio 1:3. Okay, so C divides OB, so that would mean, oh, sorry, we do have B. That's here, 1/1. But that would mean this is like a quarter of B, which would mean this is 3/4 of B. Where did I get a quarter and 3/4? Well, if it's in the ratio of 1:3, then that must be 1/4, and that must be 3/4. You add them up and divide by, well, 4. Okay, D is the midpoint of AC. Fine. So find AC. Okay, so this guy's, I think, what am I trying to find? AC. Okay, so I have from A to C, I'm going to go A to O and O to C. So that will be AC is equal to minus A, because I'm going against the A, plus 1/4 B, like that. Okay, that's part I. OD, so O to D. Now to get from O to D, I'm going to go OD is O to A and then plus A to D. Now O to A is A, and A to D is a half AC, so it's a half, well, half AC, I can write it like that, which is A plus a half. AC I have, it's minus A plus 1/4 B, and this is equal to A minus a half A, which is a half A, and then plus a half of 1/4 B, so half times 1/4 is 1/8, so that's plus 1/8 B. Part 3, B to D. Okay, so I can go from B to D, I can go minus, I can go, okay, let's just write it, B to D. I can go let's go actually, guys. B to O and then O to D. So it's B to O plus O to D. Now I have OD, it's here. So BO is just minus B, because it's like minus OB. And then OD is this. So this is plus a half A plus 1/8 B. This is equal to a half A and then minus 8/8 B plus 1/8 B is minus 7/8 B. Okay, that is part A. Part B. It says the point E is such that OE equals lambda OA. So E is somewhere on this. Okay, and he says EDB are collinear. Okay, so that means there's a line, guys, from B through D through O. Now, guys, let me just move this somewhere here. Okay, so I have this B, D, E. So that means E is here, somewhere here. Now just remember, guys, that A is obviously for the full thing. Okay, now he says OE is lambda OA. Find the value of lambda. Okay, so this is quite like those normal annoying GCSE questions. So how do we do them? Well, we go, and guys, I'm just going to move this out of the way. Let's move this over here. Now I will maybe need some of those, but just for now, let's put it out of the way. So I'm going to go from O to E two different ways. So I'm just going to say, so from O to E. So OE firstly is equal to, well, it's lambda OA, that's the first one. And we know OA is A, so it equals lambda A. Okay, fine. The second way I'll get from O to E is through this here. I'll go O to B and then B to E. Okay, so let's write this here. OE is equal to OB, OB plus, so it's OB plus BE, BE. Okay. Now I know OB, well, OB is just B. BE, I don't know, but I do know BD. So BD, guys, I got here, it's a half A minus 7/8 B. That is BD. Let me just write that here. BD is equal to a half A minus 7/8 B. Okay, so I'm going to actually say that BE is some multiple of BD. So it's B plus some multiple, let's say mu, of BD. So BD is a half A minus 7/8 B. Now I can do that because of this, and this is like a key part of the question, because they're collinear. Because they're on the same line, then BE and BD are parallel, hence it is a multiple of BD. Okay, let's just simplify this a bit. This is B plus a half mu A minus 7/8 mu B. Okay, now I have OE in two different ways. Once I get to here, the A's equal the A's and the B's equal the B's. Now there's nothing there for the B, so that's actually good. So let's just do this. Well, the whole thing. Okay, so I can say my A's equal to A's, so I can say lambda equals 1/2 mu, and I can say that the B's equal to B's, 0 equal 1 minus 7/8 mu. So let's rearrange this. 7/8 mu equals 1, which means mu must equal 8/7. If mu is 8/7, then lambda is equal to 1/2 of 8/7, which is actually equal to 4/7. Okay, so that is the answer to part B. Okay, finally, part C. Given that the area of triangle OAC, so that's this triangle here, over the area of triangle OEB is equal to mu, find the value of mu. Okay, now guys, I use mu here. Note different mu from part B. So obviously it's not, the answer is not 8/7. Okay. Area of triangle OAC over OEB is equal to mu. Okay, so firstly our OAC triangle is this triangle here. And our OEB triangle is this triangle here, OEB. Now the trick with these questions, guys, is you want to, obviously area is about base times height. So you want to kind of try and find a common base for which we know the ratio. So here we know that this is a quarter of this base, but we've got different heights because this one goes to E and this one goes to A. You could think of this space, because we know this is lambda, this is 4/7 of A. In fact, I'll just do that now, guys. This is 4/7 of A, and this is 3/7 of A. So you could do this base, but then we've got different heights because we've got this height, and for the green one is obviously this height over here, which is no good. So we essentially need a new triangle, and we're going to bring in another triangle, which is this bigger one, which is OAB here. Okay, now bear with me. I'm going to, guys, bring this all the way up here. I need this 4/7, so let's just leave that here for a second. Now I can say that, because if you look at this OAB triangle, I can say that area, I can say area of triangle, okay, the area of triangle OCA, okay, OCA is equal to, this is a quarter of the triangle OAB. OAB, because the base is the same. The base is, well, sorry, not the base is the same, but the height is the same. The height is up to A. The height goes to A, but our base here, the purple guy's base, is a quarter of the big guy's base. Okay, so I can say this. Okay, now, and I should have said, guys, a quarter of the area. A quarter of area, OAB. Okay, so that means that OCA or OAC, so 4 of these, 4 times the area of triangle, let's call it OAC is equal to the area of triangle OAB. So now I've compared the purple one to the big orange one. I'm now going to compare the green one to the big orange one. So the green area, let's call this area of triangle, the green one is OEB. So the area of OEB is equal to, because now we're sharing a base, again, look at the green triangle with the big triangle, so I'm sharing a base, this OE or OA, that's the base, and the height is the same, the height is this B here, and it doesn't matter, it's the perpendicular height, guys, but it's whatever, it's we're just dealing with ratios, so it's still going to be that height for both of them because it's that point. So OEB, well, how much smaller is the base than this guy? Well, we know it's 4/7 because the lambda is 4/7. So this guy's area is going to be 4/7 of the area of the big triangle, which is OAB. Now I'll cross multiply and I will get 7 over 4 multiplied by 7 divided by 4 of the area of triangle OEB is equal to area OAB. So now I have kind of like my two OABs, this and this. Look, I can just equate this must equal this. So 4 area triangle OAC must equal 7/4 of the area of OEB. Now what does he want? Well, he wants this over this, so if I kind of cross multiply, area of OAC, triangle OAC, over, whatever guys, I should have triangle in all these, over area of triangle OEB must equal, and then I divide by the 4, 7/16. So that means mu, let's write it here, therefore mu equals 7/16. Okay, that final question, guys, that's actually really brutal. That was a really, really difficult question, so hope you understood it. Okay, that's the paper. I'll see you for paper 2.